For this video, we're going to use Packet Tracer to identify MAC and IP addresses. For part 1, we're going to gather PDU information for our local network communication. And for part 2, gather PDU information for remote network communication. For part 1, we're going to gather PDU information for local network communication. So first, we select 172.16.31.5 and we open the command prompt. We're going to ping 172.16.31.2. And then we switch to simulation mode and repeat the ping of 172.16.31.2, and the PDU will appear next to the 172.16.31.5. Clicking this PDU shows us the OSI model and outbound PDU layers. Now we click compare/forward to move the PDU to the next device. We gather the same information from step 1, and we repeat this process until the PDU reaches its destination. Now for step 2, we're going to repeat the same process and gather the same information, but with 2 different pings. Pinging 172.16.31.2 from 172.16.31.3, and we'll also ping 172.16.31.4 from 172.16.31.5. For part 2, we're going to gather PDU information for remote network communication. In order to communicate with remote networks, a gateway device is necessary. We're going to study the process that takes place to communicate with devices on remote network. We gather PDU information as a packet travels from 172.16.31.5 to 10.10.10.2. We click 172.16.31.5 and we open the command prompt. We enter the ping command ping 10.10.10.2, and we switch to simulation mode and repeat the ping from the ping command 10.10.10.2. A PDU appears next to 172.16.31.5. We click the PDU and note the following information from the outbound PDU layer. We also click capture afterwards to move the PDU to the next device. We gather the information from step 1D and repeat this process until the PDU reaches its destination. We record the PDU information we gathered from pinging 172.16.31.5 to 10.10.10.2. So in regard to the reflection question 1, were there different types of cables/media used to connect devices? Yes, copper and fiber. Did the cables change the handling of the PDU in any way? No. Did the hub lose any of the information that is received? No. What does the hub do with MAC addresses and IP addresses? Nothing. Did the wireless access point do anything with the information given? Yes, it repackaged it as wireless Wi-Fi. Was any MAC or IP addresses lost during the wireless transfer? No. What was the highest OSI layer that the hub and access point used? Layer 1. Did the hub or access point ever replicate a PDU that was rejected with a red X? Yes. When examining the PDU details tab, which MAC address appeared first, the source or the destination? The destination appeared first. Why would the MAC addresses appear in this order? A switch can begin forwarding a frame to a known MAC address more quickly if the destination is listed first. Was there a pattern to the MAC addressing in the simulation? No. Did the switch ever replicate a PDU that was rejected with a red X? No. Every time that the PDU was sent between the 10 network and the 172 network, there was a point where the MAC addresses suddenly changed. Where did that occur? It occurred at the router. Which device uses MAC addresses starting with 00D0? This is the router. To what devices did the other MAC addresses belong? To the sender and the receiver. Did the sending and receiving IPv4 addresses switch in any of the PDUs? No. If you follow the reply to a ping, sometimes called a PONG, do the sending and receiving IPv4 addresses switch? Yes. What is the pattern to the IPv4 addressing in the simulation? Each port of a router requires a set of non-overlapping addresses. Why do IP networks need to be assigned to different ports of a router? The function of a router is to interconnect different IP networks. If this simulation was configured with IPv6 instead of IPv4, what would be different? The IPv4 addresses would be replaced with IPv6 addresses, but everything else would be the same.